Welcome back, and here's the last problem on the titration perspective in stoichiometry. So I have this problem, and as I always suggest that you pause the video here and then work it out and then come back and play the video, see if you got it right. If you didn't, write down exactly why you did not get it right. Don't just say, I did not get it right. Just write down the reason. Is it the math? Is it the concept? Or where is it exactly that you're struggling, or reasons behind your struggle? Then it's easy for me to help you when you have a particular problem. All right, as always, you got to first balance the equation. Okay. Balance the equation and then solve the problem. Okay. I am going to work it out both the traditional method and then the shortcut method. Okay, so method 1 is, get a different color. So you start with the information that contains both concentration and volume, and out of the two, if you always start with concentration, you should have absolutely no problem. So 0.5 molar is 0.5 moles over 1 liter. That's what it means. And then we got to get rid of the liter, so we convert the 20 mils to liters, which would be 0.020 liter. Because there's nothing here, we just put a 1, just like we did in the problem before. And this will give us, and then we do the stoichiometric ratio before we actually go to the next phase of the problem, next phase of the step, which is, if we balanced this equation, then we notice this is 3, and I believe this is 3 as well. Okay, so it's not what here is so much important if you're not trying to solve the product. For titration, we're usually only on the left side. We rarely ever go to the right side. So since we are starting with the acid here, which is the phosphoric acid, so the acid part would go down. So for every 1 mole of the acid, it's 3PO4, we needed 3 moles of sodium hydroxide. So that goes on the top. So if you do it the way I show you, like write numbers, units, the name of the compound, I don't see how you can ever get these things wrong. Okay, so times 3. So this is the moles of the sodium hydroxide, but is that what we want? We want the equivalence point, right? So we start with the 0.03 moles of sodium hydroxide as the given information now, and divide by 1. And then we do know the final concentration. 0.1 molar is same as 0.1 moles over 1 liter. So we put the liter on the top, the 0.1 moles on the bottom, and then we got to convert the liters to milliliters. So that would be divided by 0.1 multiplied by 1,000. So that's 300 mils. That is the answer, which is the equivalence point. This is the EQ point, or equivalence point. All right, so let's do method 2, which is the shortcut method. Again, understand the problem, then I don't care if you use method 1 or 2. It makes more sense. So now we write V acid times C acid equals V base times C base. So we write all the information given, so 20 times 20 mils, 0.5 molar equals volume of base, which is what we need. Concentration of base is 0.1 molar. Now, the important thing is put this whole thing in bracket and this whole thing in bracket. Okay? You don't need to, but it helps. And since the base is 3 and the acid's 1, we multiply the acid by 3, right? So 3 times 20 times 0.5 over 0.1. And that will give you the answer. And we should be getting 300. If not, I did do something wrong. Okay? There we go. 300 mils is the answer. You know, it's fun if you do both so that you can, you know, you don't need assurance from me. You're self-assuring yourself, saying, hey, I did it right. So do whichever method works the best for you. Some people like the full math version, which is method 1. Some people just like the shortcut version, which is method 2. All right? So either one you choose, you're going to get the right answer, and one method is no better than the other, except one method gives you more intuition into how you think than the other one, which is method 2, which is fairly easier to solve. So we've looked at solids, and we worked problems both in the forward direction and reverse stoichiometry, which is the second video. And then we looked at another video where we calculated concentration of acids and bases in a titration reaction, where we looked at 1 to 1, 1 to 3, and 1 to 2. I don't think there is 1 to 4 or 1 to 4, or I can't think of an acid with 4 protons. So it's mostly 1 2, 1 1, 1 3. Anyway, so that's where we're going to stop this video, and I'll see you with another video, so stay tuned.